Good morning, children. We all know that in the previous classes, natural calamities. So we will do the textbook exercises now. So I want you to take out your textbook and then page number 107. Okay. So you complete the textbook exercises, page number 107. Page number 107. Yes. All of you are ready? Okay. Yes. First main, that is A main, fill in the blanks. The location of a fault where the earthquake starts is called B. So what do you call where the earthquake begins? So that one is called as hypocenter. It is called hypocenter. Next. Second, the position directly above it on the ground surface is called. So inside the earth where it starts, it is called hypocenter, and on the surface of the earth where the earthquake is present or felt, it is called epicenter. Third, the record of ground shaking recorded by a seismograph is called. So the instrument is seismograph. What record it shows? It is called graph. Instrument is seismograph. What it records is called seismograph. Fourth, the strength of an earthquake is measured by a large scale. Richter scale. Last bit one. The innermost layer of the earth is called. I know that earth has 3 layers, core, crust, and mantle. The innermost layer is called core. Okay. Now we will go to the B main. B main. Write true for true or F for false statement. If an earthquake happens under the ocean, it is called tsunami. So if there is disturbance under sea, so it is called as tsunami. So the first one is true. Okay. Second, the earth is made up of 4 layers. First, just now we studied it is 3 layers: core, crust, and mantle. Third, the crust is the outer layer of the earth. Yes. The inner is core, outer is crust, and the middle is mantle. Then fourth, the second layer of the earth is called the mantle. True. Okay. Next, extinct volcanoes are those that may erupt any time or have erupted in the recent past. So that is active volcanoes. It is not extinct. Extinct is already dead. It is inactive. Okay. So these are the textbook exercises of this lesson. So completed. In the class, I'm going to check both the lesson textbook exercises. Okay. Last class also I did. Now also. So both the lesson textbook exercises I will complete. I will check in the class. Got it? Okay. Completed. Shall I erase? Okay. Now we move to the next part of the lesson. Next lesson. In the last lesson, we studied about the environment. We studied so many things are present in the environment. Is it not? Okay. Now, as soon as we get up, as soon as we wake up in the morning, we see so many things around us. And we can identify what are the things present around us. Is it not that? Okay. Now, the same thing on the other hand, if it is in the dark, if you enter into a dark room, and if I ask you to identify the things, will you be able to identify the things? No, it's not. You cannot identify the things because it is dark. Once you on the light, then you can identify the things. So by this, you can understand that we can see things only in the presence of light. If there is absence of light, we cannot see the things. We cannot notice the things, identify the things, recognize the things. Okay. So in in this lesson, we'll study about the light, shadow, and eclipses. Okay. So we will the next lesson now. Light, shadow, eclipses. Light, shadow, eclipses. What? Now, today study about light. In the absence of light, you cannot see anything. If light is present, only you can see anything. Light is a form of energy. In the dark room, we cannot see anything. In the daytime, we can identify elements which is present in the environment. Because of the presence of light, light is there, we can see. Light, we can see the things around us. Okay. Now, if light is there, how we are able to recognize, or how it is possible for us to see the object? Okay. So we are able to see the objects because when the light falls on the objects, now suppose you have a source of light. That means from where you get the light. When the light, now suppose I have an apple here. Okay. So when the source of light falls on the object, it bounces the light. That means it throws that light back and it enters into the space, and that falls on our eyes, and we are able to recognize the object. Okay. So how we are able to, in the presence of light, how we are able to recognize the objects or see the objects is, so it bounces off and travels through the space, open space, and it reaches our eyes, and our eyes will recognize what it is. Our eyes will recognize that it is apple or it is chocolate or whatever I am writing. Okay. So because of the light only, we are able to see things around us. Okay. Yes. Now here, the next part, I'm going to make two columns here and list few objects in two columns. Okay. So in the first column, I would like to write the sun, the stars. Okay. So electric bulb or candle, torch. Okay. So in one column, in the first column, I wrote all these things. In the next column, I would like to write wood, chalk, stone, leaf, moon, earth. So many examples. Moon, earth, all these things. Okay. Now, do you find any difference between the two columns? Here I have listed something: sun, stars, electric bulb, candle, torch, and here I have listed wood, chalk, earth, stone, leaf, moon. Okay. So what is the difference between, or why few things I have put in this column and these things I have put in this column? I think you have all understood, is it not? So these are the things which is going to give out light. Okay. These things which give out light. It has its own light. It gives out light. Okay. And these things does not give out light. It does not give out light. So these are the things which does not give out light. So you can say moon does not give out light. How we can say the moon? Because it takes the light from the sun and then it bounces, as I said, it bounces the light from the sun and it can be seen. Okay. So these are the things which give out light, and these are the things which do not give out light. Okay. So you can define these things. That means those things which give out light are called as luminous objects. What are they called? Luminous objects. That means objects which give out light. Okay. And the other side, they do not give out light. So you call it as non-luminous objects. Non-luminous objects. Understood what is the difference between the two sets of objects? So these things give out light, so you can call them as luminous objects. And these things does not give out light, they are called as non-luminous objects. Okay. Yes, sir. So here I have listed the thing. Even some animals give out light. Okay. So the insect called firefly. Firefly. Okay. So it gives out light during night time. Okay. There is an insect called firefly. It gives out light during the night. And deep in the ocean, there is a fish called lanternfish. Lanternfish. Okay. So this also, this is deep inside the ocean. This lanternfish also gives out light. Okay. So these are the animals which give out light. So what do we call these animals? Or the light produced by the animals is called as living light. Okay, the light, living light. Whatever the light given out by these animals is called as living light, or it is also called as bioluminescence. Okay, so bioluminescence. Okay, so that means this animal, the light given out by the animals. Other than the things, firefly and lanternfish also gives out light. So it is called as living light or bioluminescence. Okay. Yes. This is about the light. Understood now? Luminous and non-luminous. So that which gives out light are called luminous objects, and which does not give out light are called non-luminous objects. What? Now we move to the next topic. In the light, we move to the next topic. It is path of light. That means how it travels. Path of light. Now, as I said, when the light falls, when a source of light falls on an object, so it always travels in a straight line. It always travels in a straight line. Does not make out turn. So now light is falling on some object, that means it always follows the straight line. So it cannot bend and travel. It cannot make a turn. So it always travels in a straight line. So you can say that light always travels in a straight line. Okay. Straight line along which the light travels is called as ray of light. It is called ray of light. That means straight line along which it travels. It is called ray of light. Okay. Collections of ray of light. Together, we put ray of light together. Collection of ray of light. Collection of ray of light is called beam. Okay, that means so when there is collection of ray of light, it is like this. This is called as beam of light. Okay, and this beam of light always will be parallel. In geometry, you have studied about parallel lines. Do you remember? So it moves together. The lines will move together, but these lines will not meet. Okay, that is like that. So it goes along, but it will not meet. So such lines are called as parallel lines, like the railway track. So the track is there on the road, but it goes, but it will not meet like that. So these are parallel lines. These beam of light are parallel lines, parallel to each other. Okay, and then this beam of light, if it meets at a single point, okay. So if it meets at single point, if the lines meet at a single point, you call it as convergent light beam. What do you call? Convergent light beam. convergent light beam. Okay, if it meets at a single point, if the beam of light meets at a single point, you call it as convergent light. On the other hand, if it bends outwards, okay, so if the beam of light bends outwards, if it bends outwards, we call it as divergent beam of light. Divergent beam of light. Understood? So if it travels, if it meets at a single point, it is convergent light or convergent light beam, or if it bends outward, that is, if it goes away from it, it is called divergent. Okay. So we'll see the diagram now about the ray, beam of light, and divergent and convergent beam of light. Okay. So now, when I said about the ray, light travels in a straight line. This one is ray. Okay. Then collection of rays. Right. Collection of rays is called as beam of light. Beam of light. Okay. So when these rays, suppose these rays are like this. The rays are like this. So all these rays meet at a point. So the rays are coming from this way. Okay, I'm showing the arrow mark. That means it is coming from this way and meeting at point here. Meeting here. So this one you call it as convergent beam of light. From the source, here it is the light source. From that, the light is passing and it is meeting at a point. So that is called as convergent. Okay. So from the source of light, if it moves away, if the rays moves away from it like this. So it is moving in this direction. So it is going away from this. So this one we call it as divergent. Divergent beam of light. If it bends outwards, it is called as divergent beam of light. Understood? Convergent, divergent, ray and beam of light. Okay. Now next, as we said, in the presence of light only we are able to see the objects. We are able to see the objects in the presence of light. So I explained how it is possible, is it not? So when the light falls on an object, it bounces the light back and that light reaches the surface, and through that eyes we are able to identify. So that bouncing back of the light, so the bouncing of the light, bouncing of the light. So that bouncing of the light is called as reflection of light. What do you call? Reflection of light. So because of reflection of light only we are able to see the objects around us. Okay. So that bouncing back of the light is called as reflection of light. Okay. So when the light strikes any surface, we can say that it is reflected. So as there is a source of light, there is a thing. So when the light falls on an object, so that it bounces back inside. So that bouncing back is called as reflection. So as soon as the light falls on that object, it bounces back. So we say it is reflected. When the light falls on the object, we say it is reflected. Okay. So if a beam of light falls on a polished shining surface, then it is reflected back. This helps to see the image of the object kept in front of that. Okay. So the best example for this is mirror. A glass plate with silver polishing on one side reflects more of the light. This silver polished glass plate is called mirror. So mirrors are the best example or best reflectors of light. Okay. So mirrors are the best reflectors of light. Mirror is one of the best reflectors of light. So it is the best reflectors of light. Mirror is one of the best reflectors of light. Okay, so it forms a very good image of the object kept in front of it. Is it not? So now when we get here, when we look at the mirror, so our face, whatever it is, over we are, look, it shows as it is. Is it not? So that is why we can say that it is a good reflector, best reflector of light. Mirrors are the best reflector of best reflectors of the light. Okay. Now the surface, the reflection or the image formed depends upon the surface also, on where it is falling, on which it is falling. Okay. So if the reflecting surface is smooth or even, if the reflecting surface is smooth or even, then the light of rays falling on that surface will be in one direction only. It will be in one direction only. Fall in one direction only. The image will fall in one direction only. Then a proper image of the object will be formed. This is known as regular reflection of light. So then at that time, the image, whatever it is formed, will be regular. So that is called as regular reflection of light. Regular reflection of light. So if the surface is smooth or even, that means where the light is falling, the surface is smooth or even, then the image form will be clear because the light will fall in one direction only. It falls in one direction only, and we get a very good image. So such image are called as regular reflection or regular reflection of light. Okay. On the other hand, if the space or the surface is rough or uneven, what happens if the surface on which the light falls is rough or uneven? It is not proper. It is uneven. So that time what happens? The light rays falling is reflected irregularly and it scatters in all the direction. It scatters. It spreads in all the direction. Whereas in the smooth and the even surface, it falls in only one direction. But in the rough or even space, even surface, it scatters, it distributes, and the clear image will not be formed because light will not fall on that object properly. So that time the clear image will not be formed. So that time we call it as irregular reflection of light. Okay, so we call it as irregular reflection of light. Irregular reflection of light. Understood? So what is regular and irregular? Okay. So if it falls on the smooth or the even surface, the light will be falling on one direction only. The image, whatever forms, will be very clear. So that image we call it as regular reflection of light. On the other hand, if the surface is rough or uneven, so the light, whatever falls, it scatters and the image form will not be clear. In such case, we call it as irregular reflection of light. Understood? So through the diagram, we will show how there is a regular reflection of light or irregular reflection of light. Okay. So as I said, when the surface is uneven, okay. So that is like this. When the surface is uneven, so here you have a source of light. Source of light, that may be torch, candle, or sun's light. So when this is uneven surface, okay, uneven or rough surface, uneven or rough surface, we can say. So when it falls on this dot, so what happens was that what I said, the light is going to scatter because there is no level. So the light is going to scatter in all the places. In all the places. Then the image, whatever is formed, will not be proper, will not be good, will not be clear, you can say. Okay. On the other hand, if the surface is even or smooth, when the source of light falls on it, when the source of light falls on it, when the source of light falls on it, so that time it will fall, it will go in only one direction. The image, whatever is formed, will be good, clear. We get a good image. So that is why we call it as regular reflection of light. Here, because it scatters, because it spreads, because of the even surface, we call it as irregular reflection of light. Understood, all of you? Yes. Now the same thing, that is how it reflects, as I said. So even from the light from the sun also, what the white light of the sun is made up of, actually it is white. Actually it is made up of 7 colors, which is called as rainbow. Okay. So what are the 7 colors present there? It's with Gaya. You can name it as with Gaya. VIBGYOR. So you all know, is it not? V is violet, indigo, blue, green, yellow, orange, and red. These are orange and red. So these are the 7 colors which the sun, the light of the sun is made up of. So the light of the sun is made up of 7 colors. The short word is big Gaya. Okay. So this can be shown when white light passes through a prism. There is a geometrical shape called prism, like this. Okay. Geometrical shape prism like this. When the light falls on this, when the white light falls on this, so you can see the picture of spreading the light like this into 7 colors. 4, 5, 6, 7 colors. So it is violet, indigo, blue, green, yellow, orange, and so when a ray of light is passed through a prism, this is a glass prism. Okay, glass prism. So it scatters, it spreads out, forming 7 different colors. That is called as That is, this is how our rainbow is formed. So when there is sun and rain, we get a rainbow. So you can see these colors. So sun's light is also made up of 7 colors. The white light of the sun is also made up of 7 colors. Okay. Now, as I said, the mirrors are the good reflectors of the light. So how the image, what the image, or how the image formed by the mirror we will see. Okay. So reflection by a plane mirror. Reflection by a plane mirror. What are the characteristics of this? So as I said now, mirror is a good reflector of light. We can see a clear image formed by the mirror. So when we get dressed and stand in front of a mirror, so we can see the image of the mirror. Is it not? So there are some characteristics of this. Okay, how the image is formed in the mirror. So we will study the characteristics. So stand before a mirror and look at your image. So in front of the mirror you stand and look at the image. Now the position of, note the position of the image. So see how your image is. So however your image also will be formed the same, is it not? Now move forward or backward and note the movement of the image. So when see the position or the size of the image, how much it is. So stand in one place, see the image what it is, and move backward and see the image, and move front and see the image. So will you notice any difference or not? So you see that the image also appears to move in the same way. So even the image also, if you move back, the image also will move back. If you move front, the image also will move front. And even the size of the image also. So when you move back, little smaller it becomes. When you move front, it becomes bigger. Is it not? Yes, sir. So if you move 2 steps forward, image also appears to move 2 steps forward. If you are a distance of 1 meter, then an image is also for 1 meter behind in the mirror. In fact, the image is formed as far behind the mirror as object in front of it. Okay, so however it is, if you move forward, the image also will move forward. If you move back, image also will move back. Okay, it depends upon the distance how it is. And the size of the image also. If you are standing very close to that, you appear bigger. So if you move back, so the size also reduces. So that is the first characteristic of the reflection of the mirror or the mirror. So however your image is, it shows the same thing. Okay. The second one more thing, have you noticed it? So suppose you stand in front of the mirror. Okay, look at the mirror. And when I ask you to lift your right hand, okay. Now, if you see that image in the mirror, so which hand you would you can see in the mirror there? It will not be like your right hand. Since it is in the opposite. Reflection will be formed in the opposite, image will be formed in the opposite. We feel that when we are lifting the right hand, we feel that we are lifting the left hand in the mirror, and when we are lifting the left hand, we feel that we are lifting the right hand in the mirror. So why is that? Because the image will be formed in the opposite side of the source of light. Always, it is not in, suppose the source of light is this way, how I am standing, the image will not be formed next to me. Obviously, it will be formed opposite direction only, is it not? So that is why it looks, when we are lifting right, it looks as if we are lifting left, and when we are lifting left, it looks as if we are lifting right. Okay. Yes. Next, the change of size of the image formed in the mirror is known as lateral inversion. So this the change. Now, when we lift the left hand, it appears as if it is right. When we lift the right, it appears as if we have lifted the left. So this ulta, opposite formation of the image on the mirror, it is called as lateral inversion. Inversion is ulta, inversion, invert. Ulta. Okay, it is called lateral inversion. Got it? So why is that? As I said, because the image will be formed in the opposite direction of the source of light. Okay. And then notice the size of the image of different objects in a plane mirror. You see that the image formed by the mirror is of the same size as the size of the object. So how much ever size I have shown. Now suppose I take the chalk paste and I see the reflection in the mirror. So this chalk paste will be of the same size only. It will not become bigger or it will not become smaller. So size will be the same size. Same size of the object. Same size of the object. Same size of the object. Okay. So these are the three characteristics of the mirror. So first one, when we move forward, the image also moves forward. When we move backward, image also moves backward. Second characteristic is when we lift left hand in the mirror, it is shown as right, it is seen as right. And when we lift right, it is seen as left hand. Because the image will be formed always in the opposite direction of the source of light. And that is called as lateral inversion. Okay. And then the size of the object, outside whatever it is the size of the object, after reflection, when you see that size of the object in the mirror, it will be of the same size. It will be of the same size. Understood? So these are the characteristics of the mirror. Okay. And that is why when you have observed the ambulance, the words written on the ambulance, it will be ulta like this. Okay, inversion E, C, and N, A, L, U, B, M, A. M, C. So when you see on the ambulance, letters so we will this what is the inversion of the letters taken. So why is this given like this? Because suppose suppose it is helpful for the people who are moving in the vehicles in the front of, okay. So if suppose the ambulance comes from the back, the person who is driving, if he sees that image in the mirror of the vehicle. Now, as I said, as I told you the characteristic of the mirror, so it is lateral inversion. So when he sees this spelling or these words, so in his mirror, in the vehicle, in his mirror, so the letters will be proper. So when he sees that in the mirror, he can read that it is ambulance. Okay, so that is why now if you have not observed, observe this. Okay, so on the ambulance, letters will be written. So it will be helpful for the drivers who are riding the vehicle. If they see the picture of this, they can in the mirror, as it is lateral inversion. So if they see that you ulta, so he can identify that as okay. Yes. So in here I will stop. The next class will study about the different mirrors. What are the different mirrors are there, and how the images are formed in the different mirrors. Okay, children. So in this class I have given the textbook exercises. Read the textbook exercises, and when I ask, bring it to the class and show them. Okay, children. So until then, take care and bye.